Hi, my name is Dean Passion, and I am the Director of Advanced Programs at First RF Corporation. Small antennas like those used for GPS are traditionally made in a flat form factor, and that's for ease of manufacturing. So even on curved surfaces like those seen in most highly aerodynamic structures, the flat surface is a real small perturbation from the curved surface, so it's not really a big issue. However, in very high-speed platforms like reentry vehicles, this small deviation can still be a big problem. The Navy has asked us to investigate making curved surface GPS antennas for high-speed reentry vehicles. First RF is an 18-year-old small business that develops antennas and RF systems. In the first year of operation, we actually set the single-year record for the most Phase 1 SBIR wins. We are also most well known for the development and production of the antennas that helped save our service members' lives in Afghanistan and Iraq by jamming the remote operation of improvised explosive devices, or IEDs, as they're generally known. The invention behind that 300-to-1 bandwidth antenna received the Army's Top 10 Inventions of the Year award, and these crew antennas went from a Phase 1 SBIR directly to production. First RF has produced over 250,000 antennas in our facilities in Boulder, Colorado. Reentry vehicles need GPS for accurate positioning and trajectory determination during the reentry process, which of course happens at hypersonic speeds. These speeds cause temperature of the exterior antennas to rise to very high levels. The Navy needs the antennas on these types of flight bodies to conform to the surface to minimize that temperature rise and yet still be able to survive and operate at these very high temperatures. As mentioned in the last slide, the Navy needs positioning information for reentry vehicles during the very harsh environmental conditions that occur during the transition from space to the Earth's atmosphere. While the primary goal of this particular SBIR effort is to provide curved surface, highly conformal, and high temperature GPS antennas for these reentry vehicles, it was First RF's goal to improve the performance of every aspect of the antenna operation. This includes the antenna gain, the impedance bandwidth, the reliability, and the mass. First RF optimized the antenna with high temperature materials and processes to improve the performance of this conformal GPS antenna relative to conventional low-profile GPS antennas. By working to lower the Q, which effectively means broaden the bandwidth, the antenna is actually better able to handle the frequency shifting effects of the temperatures that are induced on the antenna. This, by the way, reduced the losses and decreased the mass. The lower mass is always a benefit to components for flight use, but the reduced ohmic loss provides higher antenna gain. And higher antenna gain adds margin to the link budget and ensures higher reliability in the reception of the critical navigation signals from the GPS constellation, which is what the antenna is there for. While additional antenna gain adds to the reliability of the link, the fabrication approach was guided by reliability for the hardware. The antenna assembly has reduced complexity to increase that reliability of the hardware, and of course, this improves the overall mission reliability. I am sure that many of you are familiar with the typical SIBR program progression. We developed this curved surface high temperature concept in phase 1, and we're working to build and test prototype hardware during our current phase 2 effort. Since this development is targeted for use on a program of record, the Joint Warhead Fuse Sustainment Program, there appears to be support for transition beyond the phase 2 SIBR work. We have already talked about the benefits you see listed on this slide. The higher efficiency provides improved gain for better link margin. The greater bandwidth is better able to handle the temperature effects of this type of flight profile, and the simple fabrication approach improves the reliability of the physical hardware. We have not really talked about the fact that this antenna integrates into the exact same mounting location on the reentry body. This means that there are no added high-cost platform modifications to get these benefits. We have also not spent much time on how the improved gain and link margin will give navigation information over a greater portion of the flight envelope, which decreases the dropout time for plasma blockage effects. As previously mentioned, this antenna is targeted towards the Joint Warhead Fuse Sustainment Program, which is a program of record. There are many other platforms that could benefit from this design approach. Other launch and/or reentry vehicles would be a very direct transition. But munitions of all forms, and especially hypersonic platforms of all types, could benefit in similar ways from the higher efficiency and gain, the reduced tolerance sensitivity to temperature changes from the greater bandwidth, the increased reliability from the lower complexity assembly, and the reduced mass. As I mentioned on the last slide, there are many other platforms that could potentially benefit from the improvements on this program. If you are working on these types of high-speed platforms and need better antenna solutions, please feel free to talk to me. I want to thank you for listening to this presentation, and I am happy to be able to talk about this innovative curved surface high temperature GPS antenna to support PNT needs on hypersonic platforms. First RF is a small business with a tremendous ability to meet the toughest antenna challenges. Anthony Jensen or I will be happy to talk with you further about any opportunities to use these types of conformal high temperature antenna solutions to meet your needs.